Hello, welcome to Chapter 1 of Mastering ArcGIS. This portion of the PowerPoint is Introducing GIS. I've broken down the PowerPoint into two parts, Introducing GIS, and then the second part will be Introducing ArcGIS, which will be the second in this PowerPoint series. The outline of this, two main bulleted topics: what is GIS, and some GIS applications. GIS in its simplest form is sometimes referred to as computer mapping. Most people are familiar with scaled down GIS systems like the internet site www.mapquest.com that allows the user to locate an address or determine driving directions between more than one address. This is a very specialized GIS application primarily used for determining driving directions. So what is GIS? The traditional definition of GIS is a geographic information system, and a newer term being used more often is geographic information science. One way to think of this is a software that combines the spatial mapping and analysis of database management systems. GIS can be thought of as a spatial database. That is, a GIS allows many of the normal relational database management system functions, such as searching the information by criteria, a question like how many parcels are zoned commercial, or maybe how many parcels cost over $200,000. What distinguishes a GIS from other traditional relational database management systems is how the information is referenced to some location on the Earth. That is, it relates to geography. When you add this spatial component to the system, you open up a new way that questions can be asked of the data and information. Questions can now be based on location. Say you were looking for a parcel of land to open a sports bar and you want it to be near a sports arena. Well, you know some criteria, like the parcel of land must be zoned commercial, and that's the query that we were able to ask of a traditional relational database management system. In the GIS, not only can you find all the parcels that are zoned commercial, but you could also select out a set of parcels that are within a distance of the major sports arena in the town. Say you wanted to know all the commercial parcels within a quarter-mile of the sports arena. That is an example of what a geographic information system allows you to do with spatially based information. This is, of course, a very basic example of GIS. On this next slide, we see a bullet talking about layers. I've always been told that GIS is a system of layers. From the very first time anyone started talking to me about GIS, they always described it as a system of many different thematic layers that can be overlaid, and then comparisons can be made between these layers of geographic information. Here we see a layer of elevation data. With that, there can be overlaid on top of it another layer. In this case, that's part of the Great Smoky Mountain National Park, overlaid on top of an elevation model in a part of Haywood County, North Carolina. In addition to the national park and the elevation, we can also overlay streams on top, as well as roads, parcels, or property, and we could overlay any number of other types of geographic information that we had available to us. Now, with the GIS, you can do things like create maps, graphs, and reports. You can also manage the data, analyze spatial relationships, look at overlays, keep up with the database, locate addresses like MapQuest, as well as doing routing and other utility and transportation type network analysis, just as some examples. So what kind of things can you do with the GIS? This is an example of how you can predict thistle occurrence in Badlands National Park. Basically, with this example, They know what kinds of soils and geology, vegetative communities, slope, aspect, distance to water, these kind of things that contribute to where thistle may grow, and from that they've developed a prediction map of where this thistle is likely to grow. That's a little bit more complex example than our sports arena example of locating a commercial property within a distance to a sporting arena. This is another example, the habitat prediction model developed by the researchers at Rocky Mountain Research Station. The following slides will demonstrate how the real-world processes can be modeled using a GIS. These researchers at the Rocky Mountain Research Station use some classical spatial analysis functions to look at elk habitat. The model focuses on 3 key factors shown by research to influence the suitability of habitat for elk. This model is designed to help the Forest Service evaluate different timber cutting plans that might influence wildlife such as elk. These 3 key factors that the researchers found contributed to elk habitat were forage, or where the elk could get food, which is mainly grassy understory type vegetation. Another key factor for elk habitat is cover. They also need good cover to hide from predators, as well as having cover during the really cold and really hot parts of the year. The final factor, other than forage and cover being the key factors for elk habitat, were distance to roads. Elk do not do well in close proximity to roads. So these are the key factors. Now, some traditional and classic type spatial analysis functions that they used in this project can be seen, and you can read more in depth about them in the book. One is here, reclassification. They took the polygons, or areas of forest, where they had information on what kind of forest cover and foraging areas there were in them, and they reclassified each of these forest boundaries to be they reclassified them to have a value of its worth to the elk as habitat. So reclassification, giving new values based on other information. They then took the newly reclassified polygons and they dissolved out the lines between adjacent polygons that had the same value for the new classification. So dissolve is a way to generalize the information and make larger polygons from smaller ones as long as the adjacent polygons had the same values. From there they did some proximity analysis. They found that foraging and cover are exclusive, in that where there is good foraging there is not good cover, because a good overstory of trees does not allow the grasses they need for foraging to grow. So what they found was that the edge areas between areas of good forage and good cover were areas that were the best suitability for habitat. They liked the areas where they could be close to cover as well as having good foraging. So they did some proximity analyses to determine these foraging areas, or the areas close to foraging and cover. From there they did some buffers, and they looked at proximity to roads through the buffers. They came up with an overall model to calculate suitability based on this geographic information, and from that they made an overall map and suitability model.